so similar to the one we did before, we have 4 things we don't know, A, B, C, and D. So we're going to need to have 4 equations to solve for our 4 unknowns. And so I make a note here that the setup is far more important. There's going to be a lot of algebra at the end. Don't worry so much about the algebra, but make sure that the setups make sense. So 4 equations, 4 unknowns. Let's see what we can find. So first off, they say they have a local maximum value of 3 when x is negative 2. So the points when x is negative 2, y is 3, better be on your function, right? So plugging it in just to the original function, that ordered pair had better be on your graph. So when x is negative 2, the y value should be 3. So 3 should equal negative 2 cubed plus b times negative 2 squared plus c times negative 2 plus d. And so that's what we have here. And then we just keep simplifying that as far as we can go, but that's about as good as we can get. And I call that equation 1. Check. So now that's one equation. Let's find another. So they say we have a local min of 0, so when x is 1. So when x is 1, the minimum y value should be 0. So that point had better be on your graph, right? So the y value had better be 0 when the x value was 1. And this is all just plugging into the original function. Those ordered pairs should be on your graph. Now, we know that maximums and minimums happen when your derivative is 0. So we take our derivative, so 3a squared plus 2bx plus c, and then remember c and d, a, b, c, and d are all constants, so you treat a just like you would a 5, and you treat a d just like you would a 5, so the derivative of that is just 0. And so now we know that that derivative has to be a 0 at our local max. So when x is negative 2, the derivative should be 0. So the derivative should be 0, and I'm just plugging in negative 2 into there. And we clean that up as much as we can, but it's not that much, so we'll stop there. That's equation 3. Check. And then our next equation, we do the same thing. We just need one more. So minimum value when x is 1, so the derivative had better be 0 when x is 1, and we're plugging 0. We're plugging 1 in for the x, and our derivative should be 0 at that minimum. So we have 1, 2, 3, 4 equations to solve for our 4 unknowns, and then it's just algebra from there. All I'm doing is elimination. I think I take my first 2 equations and I just subtract them to get rid of the d's. So if I just rewrote, equations 1 and 2, the d's cancel when I subtract them. So 3 minus 0 is 3, negative 8a minus a is negative 9, and then I divide everybody by 3 because I can, and then I have to stop. So now I got rid of the d's, I get rid of the d's again. So I use equations, let's see, 5 and 4. So equation 4 already doesn't have a d in it, so I combined, and equation 3 doesn't either. So I combine equation 5 and equation 3, and I just add those, and I get that. And then I combine equation 5 with 4, which also didn't have a d, and so now I've got these two. Oh, and then that one gave me the 1/3 right away, and then I just plugged that into equation 3 to get my A, and I plugged that into equation 5 to get my C, and then I plugged that into equation 2 to get my D, and I've got them all. Yeah. So don't be, it's not too terrible of algebra. Setup's more important. But yeah, it's not bad. And you can graph this on Desmos, and hopefully those points will be on the graph, and they will be maxes or mins or places where it kind of levels off. Oh no, they said it was supposed to be maxes and mins. Okay.